Yeah, hello, I'm Claus Rørbech. Welcome to today's talk on Realm Kotlin. I'm Claus Rørbech and a software engineer at MongoDB, working in the RealmJava team. And today I'm going to talk about Realm Kotlin and why we decided to build a complete new SDK. And I'll go over some of the concepts of this. We'll do this with a highlight of what Realm is, what triggered this decision of writing a new SDK instead of trying to keeping up with the RealmJava. We'll go over some central concepts as it has some key significant changes compared to RealmJava. We'll look into status, where we are in the process. We'll look into where and how it can be used, and of course, peek a bit into the future. So just to recap, what is Realm? Realm is an object database with the conventional ACID properties. It's implemented in a C++ storage engine and exposed to various language through language-specific SDKs. It's easy to use as you can define your data model directly with language constructs. It's also performant. It utilizes zero copying and lazy loading to keep memory footprint small, which is still key for mobile development. Historically, we have been offering live objects, which is a consistent view of data within each iteration of your run loop. Finally, we are offering infrastructure for notifications and easy on-device encryption and easy synchronization with MongoDB Realm. So RealmJava already works for Kotlin on Android, so why bother doing a new SDK? The goal of Realm is to simplify app development. Users want to build apps and not persistent layers. So we need to keep up providing a good developer experience around Realm with this evolving ecosystems. So why not just keep up with the RealmJava? To understand the challenge of keeping up with RealmJava, we have to have in mind that it has been around for almost a decade. Throughout that period, Android development has changed significantly. Not only has the language changed from Java to Kotlin, but there's also been multiple iterations of design guidelines. And now finally official Android architectural guidelines and components. We have kept up over the years. We've constantly done API adjustments, both based on new language features, but also from a lot of community feedback, what users would like us to do. And we have tried to accommodate this major new design approaches by adding support for the reactive frameworks, both RxJava and lately with the coroutine flows. But yeah, keeping up has become increasingly harder, not only just by the growing feature set of Realm itself, but also trying to constantly fit into this widening set of frameworks. So we thought it was a good time to reassess some of these key concepts of RealmJava. The fundamentals of RealmJava is built around live objects. They provide a consistent updated view of your data within each run loop iterations. Live data is actually quite nice, but it's also thread confined. This means that each thread needs its own instance of a realm. This realm instance needs to be explicitly closed to free up resources. And all objects obtained from this realm are also thread confined. These things has been major user obstacles because accessing objects on other threads will throw, and failing to close instances of Realm on background threads can potentially lead to growing file sizes because we cannot clean up this outdated data. So in general, it was awesome for early days Android app architectures that were quite simple, but it's less attractive for the current dominant designs that relies heavily on immutable data streaming frameworks and very flexible execution and threading models. So besides this wish of trying to redo some of the things, there's other motivations for doing this now. So namely, being Kotlin first. Android has already moved there, and almost all our users are also there. So we want to take advantage of being able to provide cleaner APIs with nice language features like null safety and inline and extension functions, and also very importantly coroutines for asynchronous operations. Another key feature of Kotlin is the Kotlin compiler plugin mechanism. This is a very powerful mechanism that can substitute our current preprocessor approach and byte manipulation approach. So instead of generating code along the user classes, we can do in-place code transformation. This reduces the amount of code we need to generate and simplifies our code weaving approach, and therefore also our internal APIs. The Kotlin compiler plugin is also faster than our current approach because we can eliminate the very slow KAPT plugin that acts as an annotation processor, but does it by requiring multiple passes to first generate stubs and then actual code for the implementation. We can also target more platforms with the compiler plugin because we eliminate the need for Google's Transform API that were only available to Android. So another key opportunity for doing this now is that we can target the Kotlin Multiplatform ecosystem. In fact, Realm's C++ storage engine is already multi-platform. It's already running on the Kotlin Multiplatform targets, with the exception of JavaScript for web. Secondly, we also find Kotlin's multi-platform approach very appealing. It allows code sharing, but also allows you to target specific portions of your app in native platform frameworks when needed, for example, UI. We think Realm fits well into this Kotlin multi-platform library suite. There's often no need for developer platform differentiation for persistence, and there's actually already quite good coverage in this library suite. Together with the Kotlin serialization and Ktor, you can actually, and Realm, you can actually do full-blown apps as shared code and only supply a platform-specific UI. So let's look into some of the key concepts of this new SDK. We'll do that by comparing it to RealmJava, and we'll start by defining a data model. Throughout all these Kotlin's code snippets, I've used the Kotlin syntax even for the RealmJava examples, just to highlight the semantic changes instead of bother with the syntactical differences. So I just need some water. So as you see, it looks more or less like Java, but there are some key things here. The compiler plugins enable us to do access the classes directly. This means that we no longer need the classes to be open, because we are not internally inheriting from the user classes. We can also just add a marker interface that we fill out by the compiler plugin instead of requiring some specific base classes. And we can derive nullability directly from the types in Kotlin instead of requiring this required annotation. Not all migration are as easy to cut down. So for our Realm configurations, we are not opting in for pure Kotlin with named parameters, but instead keeping the builder approach. This is because it's easier to discover from inside the IDE, and we also need to have in mind that we need to be interoperable with the Java. So we only offer some specific constructors with named parameters for very common use cases. Another challenge from this new tooling is that the compiler plugin has some constraints that complicates gathering default schemas. And we are not fully in place with the constraints for this yet. So for now, we've just required explicit schema definition in the configuration. For completion, I'll just also highlight the current API for performing queries on the Realm. To get immediate full query capabilities, we've just exposed the string-based parser of the underlying storage engine. This was a quick way to get full capabilities, and we'll probably add a type-safe query API later on when there's a bigger demand. Actually, this string-based query parser is also available from RealmJava recently, but users are probably more familiar with the type-based or type-safe query system. So all these changes are mostly syntactical, but the most dominant change for Realm Kotlin is the new object behavior. In Realm Kotlin, objects are no longer live, but frozen. Frozen objects are data objects tied to a specific version of the Realm. So they are immutable, you cannot update them, and they don't change over time. We still use the underlying zero copying and lazy loading mechanism, so we still keep the memory footprint small, and you can still use a frozen object to navigate the full object graph from the specific version. In Realm Kotlin, the queries also just returns frozen objects. Similarly, notifications also returns new instances of frozen objects. And with this, we have been able to lift the thread confinement constraint. This eases lifecycle management because we can now only have a single global instance of the Realm. And we can also pass these objects around between threads, which makes it way easier to use it in reactive frameworks. So again, let's look into some examples by comparing it to RealmJava. So the shareable Realm instances eases this lifecycle management. In RealmJava, we need to obtain an instance on each thread, and we also need to explicitly close this Realm instance. On Realm Kotlin, we can now do this upfront with a global instance that can be passed around between threads, and we can finally close it later on, this single instance. Of course, it has some consequences. With these shareable instances, changes are immediately available to all threads. So in RealmJava, the live data implementation only updated our view of data with in between our run loop iterations. So same query in the same scope would always yield the same result. For Realm Kotlin, with our frozen objects, so in Realm Kotlin, updates from different threads are immediately visible. This means that 2 consecutive queries might reveal different results. This also applies for local or blocking updates. Again, RealmJava, with live results, local updates were instantly visible and didn't require a refresh. For RealmJava, the original object is frozen, tied to a specific version of the realm, which means that the update weren't reflected in our original object. And to actually inspect the updates, we would have to requery the realm again. In practice, we don't expect access to these different versions to be an issue, because the primary way of reacting to changes in Realm Kotlin will be listening for changes. So in Realm Kotlin, updates are delivered as streams of immutable objects. It's implemented by coroutine flows of these frozen instances. In RealmJava, when you got notified about changes, you could basically throw away the notification object, because you could still access all data from your old existing live reference. With Realm Kotlin, this your original instance is tied to a specific version of the realm. It means that you, for each update, you would need to access the notified or the new instance supplied by the coroutine flow. But again, this updated instance gives you full access to the realm version of that object. Or it gives you full access to the object graph from this new frozen instance. So here we start to see some of the advantage of our coroutine-based API. With RealmJava, this code snippet, if it was run on a non-looper thread, it would actually not even give you any notification, because it was hard to tie the user code with our underlying notification mechanism. So for Realm Kotlin, since we're using coroutines, we use the flexibilities of this. This gives the user flexibility to supply this looper-like dispatching context, and it's easy for us to hook our event delivery up with that. Secondly, we can also now spread the operations on a flow over varying contexts. This means that we can apply all the usual flow operators, but we can also actually change the context, as our objects are not tied to a specific thread. Further, we can also, with the structural concurrency of code routines, it's easier to align our subscription with the existing app scopes. This means that you don't have to bother with closing the underlying Realm instance here. With the shareable Realm instances of Realm Kotlin, updates must be done atomically. So with RealmJava, since we had a thread-confined instance of the realm, we could just modify it. In Realm Kotlin, we have to be very explicit on when the state is changed. We therefore provide this write transaction on a separate mutable realm within a managed scope. Inside the scope, it allows us to create and update objects just as in RealmJava, but the changes are only visible to other once the scope is exited. We actually add a similar construct in RealmJava, but this is now the only way to update the realm. So inside the transaction blocks, things almost works as in RealmJava. It's the underlying same storage engine principles, and transactions are still performed on a single thread-confined live realm, which means that inside this transaction block, the objects and queries are actually live. The major key difference for the transaction block is how to update existing objects when they are now frozen. So for both SDKs, it applies that we can only do one transaction at a time, and this transaction must be done on the latest version of the realm. Therefore, when updating existing objects, we need to ensure that we have an instance that is tied to the latest version of the object. For RealmJava, we could just pass in the live objects to our transaction block, but since it could actually have, we always had to check the object for its validity. A key issue here was that since object couldn't be passed around on arbitrary threads, we had to get a non-local object. We would have to query the realm and find out a good filtering pattern to identify objects uniquely. For Realm, we have just provided an API for obtaining the latest version of an object. This works for both primary key and non-primary key objects due to some internal identifiers. And since we can now pass objects between thread, we can just pass our frozen objects in and look up the latest version. So to complete the tour, we'll just close the realm. As you've already seen, it's just easier to manage the life cycle of realm when there's one single instance. So closing an instance to free up resources and perform exclusive operations on the realm, it's just a matter of closing the shared global instance. Interacting with any object instance after you close the realm will still throw, but again, the structural concurrency of coroutine flows should assist you in stopping accessing the objects following the use cases of your app. So besides the major shift to frozen objects, we are of course trying to improve the SDKs in a lot of ways. First of all, we're trying to be idiomatic Kotlin. We want to take advantage of all the new features of the language. We're also trying to reduce size, both of our own library, but also the generated code. This is possible with the new compiler plugin. As we've previously touched, we can just modify the user instance and not generate additional classes. We're also trying to bundle up part of functionality and modularize it into support libraries. This is way easier with extension methods. So now we should be able to avoid having everybody to ship apps with the JSON import and export functionality and stuff like that. This also makes it easier to target future frameworks by offering support libraries with extension functions. As we've already also seen, we are trying to ensure that our SDK is as discoverable from the IDE directly. And we're also trying to ensure that the API is backward compatible with the Java. This might not be the most idiomatic Java, but at least we try to do it without causing major headaches. So we also want to improve testability. So we're putting in places to inject dispatchers, but most notably, we're also supplying JVM support for off-device testing. And lastly, since we're redoing an SDK, we of course have a lot of insight in the full feature set. So we also know what to target to make a more maintainable SDK. You've already seen some of the compromises throughout these slides, but please feel free to provide feedback if we can improve something. So with this new multi-platform SDK, where and how to use? We are providing our plugin and library as a Kotlin Multiplatform SDK. Just to be absolutely clear for people not familiar with the multi-platform ecosystem, this still means that you can just apply your project or apply this library and plugin on Android-only projects. It just means that we can now also target iOS and especially multi-platform and later desktop JVM. And as said, there's already libraries out there for serialization and networking. So we can, with Realm, we can already build full apps with the shared business logic and only have to supply platform-dependent UI. Thanks to the layout and metadata of our artifacts, there's actually no difference in how to apply the projects depending on which setting you're in. It integrates seamlessly with both Android and KMM projects. You just have to apply the plugin. It's already available in plugin portal, so you can just use this new plugin syntax. Then you have to add the repository, but you most likely already have Maven Central as part of your setup, and then add our dependency. There's a small caveat for Android projects before Kotlin or using Kotlin before 1.5, because the IR backend that triggers our compiler plugin is not default before that. So you would have to enable this feature in the compiler also. You already seen a model definition. It's a very tiny one. And with this ability or this new ability to share our Realm instances, we can now supply one central instance. And here I've exemplified it by using a tiny coin module. So we are able to share this instance throughout the app. And to show how it's all tied together, I have a very small view model example. This uses our central Realm instance supplied by Coin. It sets up some live data to feed the view. This live data is built up from our observable flows. You can apply the various flow operators on it, but most importantly, you can also control this context for where it's executing. And lastly, handling this in the view model scope ensures that subscription is also following the life cycle of your view model. And lastly, for completion, there's a tiny method to put some data in there. So, as you might have read between the lines, this is not all in place yet, but I'll try to give a status. We're in the middle of maturing this proof of concept of the proposed frozen architecture. This is merged into our master branch bit by bit without exposing it to the public API. There's a lot of pieces that need to fit together before we can trigger and migrate completely to this new architecture. But you can still try our library out. We have an initial developer preview in what we call version 0.10. Maybe the best label is Realm Kotlin Multiplatform Bring Up, because it sort of qualifies the overall concept in this multi-platform setting, with our compiler plugin on multiple platforms, also multi-platform C interrupt, with collecting all these native objects in the various memory management domains. As said, it doesn't include the full frozen architecture yet, so the Realm instances are still thread confined and objects are live. There's only limited support, but we have primitive types, links to other Realm objects and primary keys. You can also register for notifications, and we use this string-based queries, also briefly mentioned. It operates on Kotlin Multiplatform Mobile, which means that it's both available for Android and iOS, but only for 64-bit on both platforms. It's already available on Maven Central, so you can go and try it out, either by using our own KMM example in the repository, or build your own project following the README in the repository. So what's next? Yeah, of course, in these weeks, we're stabilizing the full frozen architecture. And our upcoming milestones are, first, we want to target the release with the major Java features. It's a lot of the other features of Realm, like lists, indexes, more detailed change listener APIs, migration for schema updates and dynamic realms, and also desktop JVM support. After that, we'll head off to build support for MongoDB Realm to be able to sync this data remotely. And when this is in place, we'll target the full feature set of RealmJava. So there's a lot of more exotic types, embedded objects, and we also just introduced new types like sets and dictionaries and any types to RealmJava. These will come in a later version on Kotlin. So we're also following the evolution of Kotlin Multiplatform. It's still only alpha, so we have to keep track of what they're doing there. And most notably, following the memory management model of Kotlin Native, there are constraints that once you pass objects around, Kotlin is freezing those. So right now you cannot just pass Realm instances around because they have to be updated, but these frozen objects can be passed around threads. Throughout this process, we'll do incremental releases, so please keep an eye open and provide feedback. So to keep up with our progress, follow us on GitHub. This is our main communication channel with the community. You can try out the sample. As said, you can also, there's instructions how to do your own Kotlin multi-platform project, and you can pick into our public design docs. They are also linked from our repository. And if you're more interested into the details of building this multi-platform SDK, you can read a blog post on how we've addressed some of this challenge with the compiler plugin and handling multi-platform C interrupts, memory management, and all this. So thank you that's all.
Thank you, Klaus. That was very enlightening. So now we'll take some of your questions. So if you have any questions, please put them in the chat. The first one here we'll mention, we've answered some of them, but the first one here is regarding the availability of the it is available now. You can go to GitHub /realm/realm-kotlin and get our developer preview. We plan to have iterative releases over the next few quarters that will add more and more functionality. The next one is regarding the migration from, I presume this user has, or James, you have a RealmJava application using RealmJava, and potentially you would be looking to migrate to Realm Kotlin. We don't plan to have like an automatic feature that would scan your code and change the APIs, because the underlying semantics have changed so much. But it is something that we can look to have like a migration guide or something like that if more users are asking about it. Really, the objects have changed from being live objects to now being frozen objects. We've also removed the threading constraint, and we've also have a single shared Realm instance, right? Whereas before, with every thread, you had to open up a new Realm instance in order to do work on that thread. So the semantics have definitely changed, so you'll have to kind of do this with developer care in order to migrate your applications over. Okay, next question here, we'll go through some of these. Does the Kotlin SDK support just KMM for syncing, or just local operations? So I can answer this one. We do plan to offer our sync, and so if you're not familiar, Realm also offers a synchronization from the local stored Realm file to MongoDB Atlas through Realm Sync, through the Realm Cloud. And so this is a way to bidirectionally sync any documents that you have stored on MongoDB Atlas down and transformed into Realm objects, and vice versa. We don't have that today, but it is something that you can look forward to the future. In the next quarters, we will be releasing our sync support for the new Realm Kotlin SDK. Other questions here. So are these transactions required to be scoped or suspended? And I presume this is using the annotations for the Kotlin coroutines keywords. So the suspend functions, the scopes functions. Klaus, do you have any thoughts on that one?
Yeah, so we are providing a default asynchronous mechanism. So, but we are also probably adding, at least already in our current prototype, we already have a blocking, right? So you will be able to do it without suspending. Yeah.
Okay, perfect. Also, in the same vein, when running a write transaction, do you get any success or failed result back in the code if the transaction was successful? So I presume this is like having some sort of callback or on success or on failure if the write transaction succeeded or failed. Do we plan to add that to our API at all?
So usually we just have exceptions if things doesn't go right, and they will propagate throughout the normal suspend throughout the coroutine mechanisms. Yeah.
Yeah, so it is a good thought though. We have had other users request this, so it's something. If we continue to get more user feedback on this, potentially we could add in the future. Another question here: is it possible to specify a path to where all the entities are loaded instead of declaring each on a set method? I'm not sure I fully follow that.
Yeah, it's when defining the schema. So yeah, we have some options of gathering this schema information, but as I stated, we are not completely on top of which constraints we want to put into it. So right now we are forced to actually define all the classes, but we have issues for addressing this, and we have investigating various options. But some of these come with different constraints, and we have to judge them along the way to see which fits best, or maybe we'll find some other ways around this. Hopefully,
yeah.
Just to add on top of this, like we could use list-off or other data structure. The only constraint at the compiler level are using class literal to specify the and since there's no reflection in Kotlin native, we don't have the mechanism like in Java to infer from your class path the class that are annotated within Java that will participate in your schema. So the lack of reflection in Kotlin native forces us to use just class and use some compiler classes to build the schema for you. constraint.
Yeah, and just to introduce everyone, this is Nabil. Nabil also works on the Realm Android team, and he's one of the lead architects and designers of our new Realm Kotlin SDK. So thank you, Nabil. Is there any known limitations with the object relations specifically running on a KMM project? My understanding is no, there shouldn't be any restrictions on object relations. Also, our types are designed, because Realm is designed to be a cross-platform SDK where you can use the same Realm file in both iOS, JavaScript, Android applications. The types are also cross-platform. So my understanding is we shouldn't have any restrictions for object relations. I don't know, Nabil or Klaus, if you can confirm or deny that.
Sorry, I lost you for a bit.
Yeah, I also lost the initial. So yeah, no, but we are supporting the full feature set. So I can't immediately come up with any constraints.
Yeah, that's
compared to RealmJava. Yeah.
Other questions here. SDK, will the Realm SDK support other platforms, not just mobile? So we talked a little bit about desktop. So I think JVM is something that we think we can get out of the box with our implementation and support. So I think for desktop JVM applications is possible.
Yeah, so internally, like I mentioned, on it, already compiling for JVM and macOS and also for ARM macOS, but we didn't expose it as a public API yet. We just wanted to focus on project supporting iOS and Android. The only issue for JVM, we have the toolchain compiling on desktop, fine, is to add the Android specific component, which are like the editor, which you don't have for desktop. So we need to find way either to integrate with Swing or to provide a hook for you to provide your looper, so it can deliver notification for you. That's the only constraint, since we are not using any other major Android specific API besides the context. So the next target that we'll try to support is JVM, but we already support it for our team internally, so it's not going to be a big issue.
And I guess in terms of web, we do have, so Realm Core, the core database is written in C++. We do have some projects to explore what it would take to compile core, Realm Core into WASM so that it could then be run into a browser. And if that is successful, then we could potentially look to have web as a target. But currently it's not part of our target right now. Other questions here. Will objects still be proxies, or will they now be the same object at runtime? For example, the object realm proxy.
There will be no proxy for Realm Kotlin. One of the benefits of using a compiler is we're modifying the object itself. Similar to what Compose is doing with the add compose. When you write a compose UI, it's modifying your function by adding some behavior. We do the same thing. Similar to what Kotlin serialization compiler is doing. So we don't use proxy objects anymore.
Okay, perfect. And then I heard at the end that Realm instances can't be frozen on native. Just wanted to confirm that. And will that throw if a freeze happens? Also wondering if that's changing or if you're waiting on the native memory model changes.
There's two aspects to what we're observing to what JetBrains are doing. Is like, first is the garbage collector. They introduce an approach where you could have some callbacks when you finalize the objects, and we rely on this to free the native resources. By native, I mean the C++ pointer. The other aspect of is the memory model itself of the Kotlin native, which is based on frozen object, or similar concept as what we used to do in RealmJava, which is a thread confinement model to achieve concurrency. So actually what we're doing is like we're trying to freeze the object graph similarly to what Kotlin does. So you can pass object between threads. The only sometimes issue is like how you interface with multi-threaded coroutine on Kotlin native. And this part is not, I think, stable yet. But in theory, our model should overlap, should work in a similar way.
I guess we don't really expect this memory management scheme from Kotlin Native to be instantly solved, but we have maybe options of providing the Realm instance in one specific instance that doesn't need to be closed on each thread, acting centrally with if our native writer and notification threads. So it might be possible in the future to define realms on each thread and interact with these central mechanisms. But I wouldn't expect the memory management constraints on native to just go away within a couple of months.
Right. Other question here: will Realm plan on supporting the Android Paging 3 API?
So you could ask the same question with RealmJava. The actual lazy loading capability of Realm doesn't require you to implement the paging library. The paging library problem is like how you can load efficiently pages of data without loading the entire data set. And since both RealmJava and Realm Kotlin uses just native pointers to the data, so as you traverse your list or collection, we only loads this object you're trying to access, and not like 100 or 200, similar to what the cursor does in SQLite, for instance. So there's no problem, similar problem in Realm in general. So we didn't try to come up with like a paging solution in the first place.
Right, and that's just from our lazy loading and memory mapped architecture, right?
Correct.
Yeah. Okay, other question here: are there any plans to support polymorphic objects in the Kotlin SDK? I can answer this. So I have just finished a product description of adding inheritance and polymorphism to not only the Kotlin SDK, but to all of our SDKs. I presume this is targeted to be like a medium-term task. It is an expensive task. But it is something that has been, highly requested for a while now, and now we have the resources to implement it. So I'd expect we would get started in the medium term to implement that.
We also have released for RealmJava what we call the polymorphic type, which is Realm Any. So you can store type Realm Any and then store in it the supported Realm type. This is pretty. You will have JSON with the dynamic types, etc. So go look at it, but it's not like the polymorphic, the full polymorphic that Ian was.
It's not like it's like a kind of our first step, I guess you could say, into polymorphism. What it enables is kind of what Nabil described is like you could have an owner field, and let's say that owner could be a business type, it could be a person, it could be an industrial, a commercial. Each of these are different classes. You now have the ability to store that type as part of that field. But it doesn't allow for true inheritance, which I think is what most people are looking for polymorphism. So that's something that is, after this is approved, going to be underway. So look forward to that. Other questions here? Any other questions? Anything I missed? I think we've gone through all of them. Thank you to the Android team. Here's Christian, the lead of our Android team, on as well. He's been answering a lot of questions. Thank you, Christian. But if any other questions here, please reach out. Otherwise, we will close a little bit early. Okay, well, thank you so much, everyone. Klaus, thank you. I really appreciate it. Thank you for putting this together. This will be posted on YouTube. Any other questions, please go to /realm/realm-kotlin on our GitHub. You can file an issue there. You can ask questions. There's also forums.realm.io. And we look forward to hearing from you. Okay, thanks, everyone. Bye.
See you online. Cheers.